Martin,
Oh,
Hello.
how are you doing?
pretty good. What about you?
Not too bad, not too bad. We should have more time to actually write and work on some spec rules, but I think I finally get time this week to put some work in. Because we need to do a lot of cleanups. It's one thing that I think we have to, yeah, we can discuss it later. Essentially, we have to probably don't do close one issue with one pull request. I should probably do them in bulk because otherwise I have management overhead. So
Yeah.
hi Derek, hi Shane.
Look,
Yeah, I put the key lookup discussion back on. There was a lot of input. I also talked to Kamil, got a bit his input. Let's see. Is he here today? No, he's not here today.
It seems like he's joining or connecting right now.
Okay, Stephen, I'll wait for your pull request. And Kamil, also, I need a pull request. Okay. Are we complete?
we're still missing some people.
Just going through. Martin, you're here.
Yeah, it looks
Pascal,
like
Derek is here. Shane is here.
I think we're missing the Wondergraph people.
Yeah. Okay, and let's give it 2 more minutes. They're not here. They can join. Doesn't matter.
Hello.
Hi, Kamil. Okay. Let me share the agenda. Okay, let's get it started. Hi, everyone. Let's start the meeting by all remembering that we follow here the spec membership agreement and the GraphQL Foundation Code of Conduct. All the agreements can be found in the agenda here. And let's kick it off by doing a quick round of introduction. And I'm starting with myself, and then we go in the order of the agenda. I'm Michael, and I'm the host today.
Look, I'm Shane from Apollo.
Hi, I'm Pascal from Chili Cream.
Hey, Derek from Apollo.
I think David just joined.
Yeah, sorry I'm late. I think Sergey's running late as well, but I'm David from Undergraph.
And I'm Martin from Apollo.
Hi, I'm Steven of Netflix.
Kamil from the guild.
Awesome. I think that's everyone. So we talked a lot about keys last week. And this is a discussion I think takes us maybe 2 more times to get through, because there's a lot of input and a lot of like views on this, and that's really good. because it really makes it much more clearer what we think about what are keys and what are lookups. And let me just scroll to Martin's here. So in Apollo Federation, the key is really defining what a lookup expects as an entry point for the reference resolver, which is hidden. This is really different in this specification, because here we define the lookup, which is also the entry point, right? But we define it kind of explicitly, and that is a bit the contention where we have to find how they play together, and where they are not needed together, where they can work on their own in parts. So one thing, Martin wrote a good gist. If you have not read it, I'm just posting it into the Slack channel, not in the Slack channel, in the meeting channel. So I think there are a couple of, wait, just let me post that in here. Then yeah. So there are a couple of, first, did everybody read that? Or did anybody not read it? Okay, I take that everybody knows when I'm diving in there. So one thing that Martin describes here is that the keys in the composite schema specification is basically the exit of a graph, whereas the lookup is the entry. In Apollo, in Apollo Federation, they are basically both at the same time, right?
So we do have the resolvable false option,
yeah,
which sort of makes something not an entry point.
It's just the exit point in that case.
Yeah.
Yes. Yeah. Yes, and that's also different to us because we don't have that.
Maybe.
Yes, because we don't need it.
Yeah.
Maybe Martin, if you could just go through. I mean, I've read it, and but if you could just explain the thoughts, because there's a few terminology in here which are interesting, so that that everyone knows what we're talking about with the entry and exit points. That we're on the same page.
You want to sum it up, Martin? Yeah, go ahead.
Yeah, but maybe I should share my screen then, so I can sort of show the examples while I go through it. Hope this works.
And wait, let me see. Yeah, you should be able to share.
No, it doesn't, because that's what I was afraid of. It's a new machine, so
Okay, then
there's this
if you
weird
instruct
permission
me,
issue.
I can scroll to it.
I need to, because I think I can turn on the permission, but then it probably needs to restart.
Yeah, if you're on a Mac.
Yeah. So
you have to restart the Zoom. You don't have to restart the whole system, but yeah.
Yeah, just the Zoom.
This is Zoom. Well, maybe that's worth it. Should only take a few seconds. Okay, I'll be right back.
Yeah, it's the first thing when you have your Mac newly set up. It's the first thing to open everything.
Yeah, and you do
Well, it's a permissions thing, right? It's a security thing. Do you allow it to use your camera or whatever?
Exactly.
Right? It's not a bad thing, but yes, it is.
You have to do it for Teams, for Google Meets, for everything.
Yeah, it's and basically it's all every 2 years or so when you get a new machine.
Yeah.
Okay, go ahead.
So, can you see my screen?
Yes.
Because I can't see it anymore.
You might be sharing different screen. Oh, now we see the lookup. Yeah.
Yeah.
Okay,
We see
great.
the lookup.
Great. Yeah. So as Michael explained, the main thing I tried to clarify here is the difference between sort of entry points and exit points. So the main thing federated execution requires is the ability to sort of traverse across subgraphs, and that means we need some way to identify sort of corresponding entry and exit points in the graph. And that's what we've been using entities for in Apollo Federation. And we identify entities by key. That's sort of a representation of the identity. But for the composite schemas specification, because we're trying to replace the query underscore entities field with a lookup mechanism, we can actually separate the two uses of keys in Apollo Federation. So the entry point, that's the lookup, and the semantics of lookup don't directly refer to keys. Basically, all lookup tells you is that there's a relationship between the arguments and the fields of the return type of a lookup field. So in this case, like the returned product, the UPC field has to match the UPC argument if you return a product. And that's sort of a very, like for humans, this is a very obvious thing. If you just look at the naming, it's just sort of the intended semantics. But the reason we need lookup is because it's not actually something that we can infer just from the GraphQL type system.
But there's one annotation actually at this point, because I think it's more than just that it matches UPC. Like a lookup function has to be stable, right? So if you run it 2 times, it will give you also the same data out.
I'm not sure
data can
that's
change, but data can change. But if you run it on the same data set, let's say it like this, it must be stable. Otherwise, the gateway has a problem.
The keys need to be stable, but it's an interesting question whether other fields, like what the time scale is.
What was the wording? While under an entity under the same identity will not change, can contribute new fields but will not change. So it can change under the same key, but the key has to be stable.
Yeah. I mean, it has to be the same entity. That's the thing. But other fields may actually change.
It's not the data that comes out, but it must refer to the same thing.
Yeah.
What you're asking for.
Yeah, I think we're all in agreement on that part. I think the right at the start here, the questions I have around when you say that, the fact that the query.product field is annotated with lookup, that indicates that the arguments of this field are related to the return type of that field.
Yeah.
Do we want to say in the spec that they're just related, or that they are in fact key fields, like they're matching, they must be matching into the key arguments in some degree, like there must be, or you must be able to select the keys through the lookup, or is it just like this is a lookup and I can use any random field that maybe somehow uniquely identifies, but doesn't have to be the exit keys that I use like explicitly.
Exactly. Yeah, because I think there are other use cases for that match. Like for instance, you could have a category string or something in a product by category field. In theory, that could even be a lookup. Like it guarantees something about the category field of the returned products. I don't know if that's as useful, and I definitely don't think it's something that we necessarily need to support or describe here, but I do think there's a usage of those lookup semantics that goes beyond just like identifying an entity by key.
Yeah, I think that makes sense from the human perspective, that I might not always have the matching exit keys for the entry keys to like match them together. But this is where we get into like the validations and the spec, the computer part of it. Like, how does like a composite spec planner at runtime gonna know like this is when I have these things, I must go to this lookup. Like it's gonna have to like figure that out, right? So like
Yeah.
there probably needs to be some check and safety that like the entry point that I'm using is an exit point from somewhere, right? Like otherwise it's just kind of pointless. Like if there's
Well,
Yeah,
but
I
it,
mean,
but it works the other way around. Like you're whenever you need to traverse like to another subgraph because there's a field, for instance, that subgraph adds to an entity, um, just as in the sort of the current version of Apollo Federation, you look at the available keys at that point, so sort of the exit points in this terminology, and then you're looking for corresponding entry points. So
yes.
that might
It's
even mean like an extra hop to convert like a key from one type to another, for instance.
Yeah, it's a bit more, right? You look at the possible subgraphs that could provide a field, and then you look at the lookups that are available to get the various points where you could get this information.
Yeah.
And then it's like a requirement basically that you then have to resolve.
I'm wondering about sort of the right order here because I mean if everyone has read this, then maybe I don't need to go over it, but for clarity, maybe I should go over the second part of this as well.
Yeah, just go over it because like there are a couple of things that I think don't work out that we have to discuss how we want to tackle them, and also for clarity, like for people who watch maybe the video later, it would be good.
Yeah.
One quick thing to note. As I read it the first time, I haven't understood it, but I believe I have understood it now the second time. The thing about exits is something which we now talk about, the entry point and the exit point. And I think what's important is to note, to understand this easier, is that the exit point is not the exit point of this subgraph. It's actually with the key you define the exit point on another subgraph, right?
No,
You're defining sort of the potential exit points for this subgraph, and then depending on where you need to go, you're looking for sort of corresponding entry points in other
Yeah, but it
subgraphs.
doesn't mean that I cannot, if I have an ID and it's not annotated as a key, I can still traverse if I have the ID to the product subgraph, right?
No, you actually because an exit point needs to be an entity, and marking something with a key makes it an entity. That sort of that guarantees the key semantics. So it's sort of it tells you that ID is a field that's meant to be stable, that's sort of implicitly shareable, and all those things.
So that means that you at least need to have the key. So to use UPC, you have to annotate UPC in at least two subgraphs, otherwise it will not be used.
No, it could be an exit point in one subgraph and an entry in another, I think.
Well, I think Pascal is asking, what if there is actually we add the field there as an ID, that's our key, right? And then another graph actually has the UPC key, and we have a UPC field here, but it's not marked as a key. So what actually happens in that case? But that is actually, I think that should be probably a warning and a composition kind of level. But I was wondering though. So when we're talking about like the exits and you know, entry points, right? So entry points, well, it's pretty easy how we enter the graph, right? Exit points, they have to point to another entry. So maybe could be better like a join points or something like that. I don't know what it is.
Yeah, like I'm also finding exit point as a term not correct, because it's sometimes not the full exit point that you have. You might need to collect more for
No, a key is meant to be a full exit point always. That's the
but
difference between lookup. Yeah.
like a composite, a key that consists of multiple parts could be collected across multiple subgraphs, right?
Yeah, but it's still one key directive that specifies the whole key.
Yes. But like when I read it the first time, like exit point is like, okay, I'm on this subgraph and now I have I can get from this subgraph the full key, but that's not always true. Like it's not a full exit point in this sense.
Yeah.
Like it sounded like final, but it's sometimes you have to go through more subgraphs to actually get the key for a lookup. Anyway.
Yeah, and like the terminology is just like a proposal, and if entry and exit points is not the right terminology, we can come up with something different. But I think for now,
Like
maybe
entry point, I really like and like I have started on incorporating that in the spec text because that's a good point for what lookup means.
Yeah. So let me quickly go through the rest of this so we have sort of a shared understanding of the basics here. So
Okay.
this is a very simple example of a lookup field. We obviously also support more complex lookups, compound keys, and this isn't even talking about like the mappings with is that we also support. But the point here is that like in many cases, like there is a direct correspondence between the lookup and the key, both for simple keys and for compound keys, as in this example with the seller ID. But that's not a necessity, and there are cases where sort of decoupling the lookup from the key makes sense. One such case is the multi-stage lookups that we also discussed last week. So obviously you could have a root field here that like allows you to input both the seller ID and a SKU at the same time and returns a product. But from a client perspective, that's not an access pattern that's necessarily a natural way of entering the graph. And obviously, for if you have multiple ways of getting to, for instance, a seller, that would then mean you also need to add like even more root fields to get at the product if you get to a seller by ID, but also by another key, for instance. So this is a natural access pattern from a client perspective, and the question is sort of how would you support this with the lookup and key semantics? And I think in this proposal, because we're separating the notion of lookup semantics from keys, there is a natural way of looking at this. So both the query seller field and the seller product field, they obey lookup semantics. Like when you ask for a seller by ID, you get back a seller with that ID, and when you then ask for a product with a SKU, you get back a product with that SKU. But that doesn't mean that there is a corresponding key.
This case, by the way, has multiple issues, and we have to talk about that. But
yeah,
like
definitely.
I think finish it off and then can.
Yeah, well, I mean, maybe like the other cases here are a little bit more complicated. Maybe I'll just cover this one and leave the other examples here out for now. But here, for instance, you have a way of getting to a product by SKU, but we're not actually exposing the SKU on product as a key, or maybe we don't expose it at all. So you can definitely enter the graph with a seller ID and a product SKU, but you can only exit this graph with a UPC in this case. That's another example of sort of decoupling the lookup from the key. And this was an attempt to clarify sort of why I think that makes sense. Like if you there isn't necessarily a direct correspondence between how you enter the graph and how you exit the graph. You could enter the graph through any possible field, like a top products, for instance, which returns a list of products. That doesn't tell you anything about the keys. Like there's no input that corresponds to a key. But you, as part of the contract, you could still state that every product you return in this list has a UPC key as an exit point.
But this kind of is like not really rectifying why you have to have a key, right? When you define an entry point, you define data that you need for this entry point. This could be any shareable data, technically.
Yeah. But key is like the key semantics are more specific. What we're saying here is that product is an entity that the UPC field is a like a durable field that doesn't change. It's also implicitly shareable because of the way we've defined the key semantics. But it's saying like without the key here, I don't think we should be able to use the UPC value as an input to another entry point on another subgraph. Like I think only entities should define exit points, and that's what the key directive is for.
Yeah, I think that there was like basically there's like a couple of things, right? So lookups overall, or a combination of lookups, they should result in an entity, right? So even though you have those nested lookups that can be combined,
they don't necessarily need to return an entity. I mean that's how they're used.
But that's my case, right? So like if you have a nested lookups, right, they could both together result in an entity, right? But having a lookup by itself that's not using any other combination, returning non-entity, that seems odd, and I'm not sure what would be the use case there.
I mean, the lookup and what it returns, we really have to specify a lot clearer, because this is really crucial. Can I take over the screen, Martin?
Yeah,
because
of course.
I have a couple of examples. And let me see this one. Oh, let's start with.
Could you make the screen bigger once you find the right one?
Yeah, I will. So let's start with this one, right? This one, I think. So the first thing is, at the moment, I'm looking at the nested lookups in kind of, do we want to have them for version 1? If we want to have them for version 1, do we have a concrete use case for them? Because at the moment, I see them as still very problematic, and they are complicating the things with the keys, and also complicating a lot of other things. So why do I say that? If we look, and let me take that away. Let's say this is the seller, and we have here an owner. And in this case, it's clear, right? We have here seller, we can enter through seller, then we can go through product, which is also a lookup. And we can resolve this product here. And we also can identify it because we have this key. But there could be also, and it might not make sense for this example, but I could maybe have 2 lookups for SKU here for product. And this is just a related product from a different, that I don't really have, like that is not my product, but a related product that I can refer to it. Like example makes no sense, but I could define that both return product, both are lookups. They get the same input, but they return semantically something different. And it took me a while to put my finger on it. But the problem is the key now is not anymore clear, because what the key makes here is the way I get to the data. And like, the main question is, do we need to have nested lookups for version 1? Because I think there are a couple of use cases in here, but we haven't fully defined them, what they are. And I think we can reach everything that we actually have with nested lookups, in version 1 at least, by having a simpler lookup initially. I don't know what the feeling is, but like, if we look at just this example, we could forbid it. We could say, okay, if you have nested lookups, you are never allowed but to have two lookup fields that return the same thing but are semantically something different. We could also limit this kind of. But as soon as you have this, right, this really messes up what this means.
Mike, Michael, maybe write the function chain below, because then it becomes very clear. So when you think about it in functional programming, and you think about that this is a idempotent function which always honors the identity, then these two things are the same thing. They're the same thing.
Yeah, but they are not the same thing, right? Related is a different semantics now.
As a lookup, by definition of the lookup, these are the same thing, because the product doesn't know what it is. The product field and the related field is just a lookup. And the definition of a lookup is, if I pass in an ID in the first one, if I pass in 1 in the first one, I get back a seller with ID 1. And if I pass in the SKU 2 in the second one, the definition of the lookup is I get back a product with SKU 2. So in these cases, that's going to be a problem. Whereas it gets very interesting as soon as you have two keys, because what you can do as the input types in Federation, as the keys are input and output in Federation, this works. You can have a key owner ID SKU, and you can have a second field, I don't know, related owner or whatever, related ID SKU, and it works because you define the input as well. And we can do this in the composite schema too, in the case that we have two different lookups in the root, right? That's how you would do it. You would say that you have the related seller up there, product by seller ID and product by related seller ID. And then you can do this. But in the nested case, you don't know which one it is, because they should actually return the same thing.
Yeah, and I think that the main issue here is that owner, like there are no guaranteed semantics for the owner field in product. There's no, like, the relationship is implicit.
Exactly, because we don't know, like, the key is downward, but like, it doesn't make, like, there is semantics in the call path, and it doesn't capture that.
Yeah.
And I think that is a problem, and that's why I would abandon nested lookups for version 1, because then we can focus on making lookups, right? And actually, if you look at this key, just by defining this lookup, it works, right?
I'm not sure. I don't think that's necessarily
the same thing. But like, this key is owner, like owner.
Oh, yes. Oh, yeah. If that's owner, and if it returns a product.
Yeah.
Yeah.
Yeah. I'm just saying we could model it differently. But Stephen, I ignored you.
Yeah, well, first, I like the idea. I was actually going to propose already for V1 eliminating nested lookups, but I was like, oh, but is this too much? I'm already stirring things up with the singular keys. So I'm glad that you proposed it also. But second, I think this is a separate issue that you're highlighting here that exists even without nested lookup. And like, as Derek mentioned, like, should this be a composition error? Specifically, should be a composition error to have multiple lookups that use the same key in your subgraph.
Yeah.
Yes.
Because it's ambiguous. When we
On the same
went down this
subgraph,
path
right?
several years ago with Falcor. We called, instead of lookup, we had a very similar directive we called canonical. And that the term was meant to indicate like this is the canonical place to find this. So like by definition, there's only one of those for each given entity.
Oops.
Yeah.
To maybe answer
Yeah,
my question,
this is one thing. I'm gonna.
I think it's totally possible for V1, and maybe you can speak up now, but I think it's possible we could, for V1, say every lookup must be a root field, and like there's no nested lookups allowed. Like if we enforce that, that would just basically force everyone to add all their lookups to the root
Yeah.
entry key, and they would have to probably go change all their schemas a little bit to like make and be composite schema compatible and have lookups, but it's technically feasible. We could still power all the features if everything needed to be a root entry field, correct? I think we're all in agreement.
Yeah.
Am I missing anything there?
No,
Yeah,
I
it's
think
all-
I think the main reason for supporting nested lookups would be if we wanted to ensure that we could sort of overlay these directives on top of existing schemas without the need
Yeah.
to change them.
Yes, but so I thought about this a bit, and I do want to embrace that, but I want to have clearer use cases for that to understand the problem area there before we commit and add this complexity. And I think, like also when you look at Apollo Federation today, it doesn't have a mechanism for these kind of things. And I think we are not like breaking any functionality for people that do want to build a federated schema. It's just
Yeah.
gives us more time to get it right and put it maybe in V2 if we figured it out.
I fully agree with that, but it does mean we're abandoning the goal for V1 of being able to like support arbitrary schemas without changing them. And that's fine, I think, but it's just something we need to call out maybe.
Yeah, but it's not fully abandoned, right? It's just if you have these, like if you have entities with stable keys in your public schema, it would fully work, right? It's only if you have these structures where you don't have a clear key and would need to go through nested lookups.
So I would argue that the scenario that you show over here that's ambiguous for product, SKU, string, and related, it could be ambiguous regardless whether it's nested or not. Even if it's a root thing, it's there. It's the same kind. It's kind of confusing, right? I think part of it is actually could be solved by saying composition, right, shouldn't allow you to have those lookups with the same keys for like, or same arguments for you know, different paths to it. I think that could solve that, resolve that ambiguity, because I think there's the underlying thing that Martin wanted to show, that the lookups don't have this correspondence to the keys, and those are two separate concepts, right? And I was thinking, like, one, why would you ever have a lookup that doesn't return an entity with a key? Well, technically it points to an entity that's extended from another graph, but you don't have exit points from there, right? So you have a lookup that returns something without a key, right? So that's still a valid scenario like that you basically can extend it, but you don't jump out of it anywhere else. It's just it does take a while to get understanding of how those all should work together.
Pascal?
Yeah, small thing. I just want to mention that the underscore entities field federation is actually just a lookup, right? So it can be used. We can use it to in with the idea of a lookup. And if you think about it, if you want to take this and lay it into your schema, there must be it must be possible to do this. And this is what we can 100% say. Like, you can define the resolver for all of the entities fields that you have. That's for all of the entity resolvers that you have. without nested lookups. So a lift and shift, like if you want to go with the composite schema specification, is something which is possible without having the nested lookups.
Oh yeah, no, definitely. I think the use case was schemas that do not currently support federation.
Yeah, if you wanted to integrate, for instance, GitHub without changing the implementation, there would actually be, like in this particular case, we would now have a problem. If there is no alternative key and an alternative entry point for instance, repositories.
I think the GitHub API actually supports Node for all its entities. So.
Yeah. I mean, it's very theoretical, and that's why I think, like, it's not completely abandoning, like, integrating arbitrary schemas, but it's more kind of we don't allow a certain case of it in version 1, and I think that removes a lot of complexities around keys and lookups that.
Yeah. I think it might still be useful to think things through, just to make sure that we're not sort of painting ourselves in a corner and are not able to support these cases later on.
Yeah, I agree.
Yeah, and also, like, we basically preserve option value with that. We write it a bit stricter, and then later we can introduce these things. Derek?
Yeah, I was gonna say, it's I don't know if the nested lookups actually complicate things much more or not, but part of it is actually, I think, what made it valid, this product and related example here, is that the validation would say that SKU cannot be a key that is actually there, because you could look it up by SKUs, but it's not your jump to another graph as a key. So your resolver for product or related product would return you something, but it's I guess would not be unique identifier. Actually, is that actually true?
Yeah. Actually, I had an issue with this too, and I think we're not the best example, because even if you just look at this from GraphQL not lookup perspective, you're missing information in line 9. Like line 9 would definitely have another argument, which would be a different seller ID. If it is a totally different seller, that would uniquely identify.
It's constructed example.
But if we did that, then it in theory could be another lookup. Like if line 9, the field was the arguments were seller ID and SKU, it could be a different lookup, right? Like there could be 2 lookups you could get to it.
You run into the same issue. Like if you just do the related seller on the product and add 2 keys, then you have exactly the same issue. You don't have enough context information to know which lookup you should take. So if you now duplicate the key on line 12, we have exactly the same issue. You don't know which identity is actually the identity that you want, because both identities are exactly the same, even though they're not.
No. Well, this should, like, if we state that this is a stable key to get here, we could take any and could get the same instance.
So it must just be the same. That the owner would be the related seller at the same time. That's essentially what this would say. Right?
No, it just says that this combination, the combination of this key is a key that identifies this entity, but also this and this together identifies this entity.
Exactly, but in case of we want to use lookups, now you could remove the line 9, then you run into the same issue. It's not clear how you get there, right?
Well, so the problem is, like, how do you differentiate from the lookup itself? The lookup doesn't give you enough semantics to know that you have to look at the resolver name to find out that how you're actually nesting it underneath it. It seems like but it's even without the nested lookups, I think it's the same thing. Like how you're actually getting the same problem, ambiguity there.
Yeah, you can't really differentiate between the owner and the related role with a like seller by ID lookup.
Yeah, there are a lot of combinations in here that introduce ambiguity to the whole construct.
Yeah,
this one doesn't, though.
Pardon?
This doesn't, though. There's no ambiguity here.
No, because this makes it you can pick any of the keys to identify it, right?
But at the end of the day, a product is identified by a seller ID and SKU. Doesn't matter whether it's called a related seller or seller A or seller B, it's still a seller and SKU combination. So like there's no ambiguity in this definition.
No, I actually think the two key directives here
Right.
they're conflicting
Yeah.
because it's not the same identity. Like you're not identifying the same entity here if owner and related are different. Does that make sense?
Yeah.
Yeah, I guess this is now that you're talking about your data models versus like the
Yeah.
schema models. And I in that sense, yes. But like if we just were to change all the names of the fields to random characters, like this technically would make sense in terms of what you were trying to say. There's multiple ways you can identify this type we happen to call product. And like I think this would make sense from a schema composition perspective.
Yeah.
You'd probably run into a runtime bug if you actually tried doing this. But like from a composition perspective, if we want to support this, I think this should totally be allowed. Like the
But
rules should pass this.
But how do you? I mean, but there is an ambiguity in the
Yes.
planning process. Like how do you decide which seller ID to use to jump to another graph?
That's a problem. If this is
You would have to go
1
and look
this
at
is
which graph
2,
you're jumping to and which entry point, which
No, but
we didn't quite get back to is like every exit point would need to have not a matching, but if you want every entry point would need to have some matching exit point to get
yeah,
from.
but
It's the same lookup.
But yeah, the entry point can't differentiate between owner and related. So the like both keys here are a combination of seller ID and SKU. So how do we decide which combination of seller ID and SKU to use here to jump to another subgraph?
and let's say this one looks it up by owner.
And this is not even directly related to the nesting. This would be ambiguous even if we just had an owner ID and a related ID.
Right. Sorry, yeah, I see it now. Yeah, okay.
But you could make it work with root lookups, right? I mean, you could validate it in satisfiability because you can actually tell in a product lookup, you can actually say which seller ID it is. So you can say that this is actually the seller ID with the is directive. You can say that you also have to change the seller return type to product, otherwise it's really confusing.
But what this one?
No, from this field, the return type should be product, not seller.
Yeah, sorry.
Because here
Product.
in here you can actually say that this is the owner ID, and then it's clear which key identifies it, right?
Yeah.
So that's one of the ways how you can.
But you cannot here because you can only refer downwards and not upwards, and that I think is my whole problem with the nested lookups. That's not precise actually.
The only way how you could use the nested lookups in the current form, if you think about it, is if you treat them kind of like we treat data. So you have to have the same shape in the same structure to actually make it work. So you have to have seller ID and then product, and only this nested way is uniquely identifiable, right? You have to have the same structure. It always needs to be across all subgraphs. There needs to be a seller with a product, and only this would be uniquely identifiable. And this then
they become inflexible.
It loses.
Yeah, I think the only way to make this work is to add extra information to the lookup directive on line 8 in this case, because what we actually want to say is that there is a correspondence between the ID of the seller on which this product field is defined and either the owner or the related seller field of product. So there's some kind of mapping here that's missing.
Yeah, the mapping, you're saying there's line 7 means something to line 8 in the lookup defined there.
Exactly.
Yes.
Yeah, because that's what I mean with the problem is the key direction is in the wrong direction. So you actually have here
It's not necessarily
resolver
wrong, but
pass.
there's just something missing.
Yes, yeah, like you have to bring in somewhere the information
Yeah.
what the lookup combination actually does.
Yeah.
Semantically, like the semantic is not clear. Like what is the semantic of these combined lookups here? Yeah, but I think like there are ways to define that. The question is just if we want to figure that out for version 1, or if we can drop it and then pick it up for version 2.
Well, it would be nice to at least have an idea of sort of what a potential solution could look like, just to make sure that we're not like stopping ourselves from supporting it in the future.
Yeah.
Martin did bring up a good point in his document at the end, which is, I think, a good wrinkle for us to consider, which is the idea of like, well, a lot of people also use, maybe just not that one, the lookup for name spacing. Okay, maybe it was in the example.
Yeah, that was on a comment, I think, to your
yeah.
Yes,
Yeah, that's what it was. So
yeah, that could
it doesn't make it. It actually makes it a little bit easier because you don't have to necessarily worry about keys per se, but like
that I think that could be one exception that we can have for version 1 without having the whole complexity of supporting actually arguments, right? But what I could see is that, for example, you put all your internal lookups in a subtype so that they don't collide with anything else.
Yes, I mean that is possible with the internal directive, right?
Yeah, but
you already could say that you have a lookup type.
It's more about root types that have yeah. So the lookup is internal, but now you have to return this from the root, and this probably is also a lookup, right?
so then
No, that we have allowed like this. You can do this,
and you don't have to specify that this is a lookup. It takes all the lookup.
No, what we say in the specification is that as long as here's no argument, like you can get to the lookup field without an argument, it's not a problem. You can, it's specifically called out that you can do that to kind of isolate internal lookups easily.
So then the lookups themselves must be able to be completely identifiable.
Yeah, the lookups are here fine.
The argument within the field.
Yeah, because there's no argument. I can just get through the lookups. There's no ambiguity here. You can get, even if you go 3 or 5 levels deep, I mean, makes no sense. But from the spec, this doesn't matter. You can get through the lookups without introducing ambiguity here. And because it's internal, and we said internal kind of is internal to the subgraph, like we already have with the lookups themselves, all these lookups don't even go to the merge process. So this lookup type could exist on a second subgraph and it would be ignored. Like they would not be merged.
I guess a simpler way to put it then is you don't have to specify anything about root types or nesting or arguments. It's just when you define a lookup and it's on a field, you must be able to see all the context looking solely at that field, like of the that you need to resolve a lookup. Like if you're going back to your example, like line 7 there defines all the context you need to look up to do a lookup. That's it. Like you just need to look at line 7. That's it. Like,
and if you put it like that, that also means that on line 12, if we included sort of a mapping syntax, that could also satisfy that.
Yeah, here we also have lookup fields must be accessible from the query type. If not directly on the query type, they must be accessible via fields that do not require arguments themselves, starting from the query root type.
Sergey has his hand up.
Sorry, Sergey, go ahead.
Yeah, as a bit newcomer to the topic of lookups as a fresh site, like as I understand, we are trying to address the problem that actual entities queries doesn't look like entity like regular GraphQL query, and it has untyped arguments. But everything which we discussing right now looks overcomplicated. Like it is not solving the exact problem which like Getaway having. And when you look onto the very plans, well, what exactly are you doing? First question: why lookup needs to be public?
It doesn't.
We
It
are
is not
trying.
public.
Will it be accessible in the query itself?
They can be public if you want them as entry point for your API consumer, but they don't have to. That's the exact thing that you have here. If a lookup is internal, then it's gone. It's just private to the private, is internal to the subgraph.
Yeah, okay. Then second question is more about execution. Like currently, entity entry point is allowing to do a batch.
Yeah, that's
calls.
also so what we have
How it is
there.
possible with lookups, and do you have an ideas like
Yes.
how entity call with lookup will look like?
Yes. So we have introduced a new batching protocol to the transport specification, which transparently allows to batch lookups. We call that the variable batching. But for legacy GraphQL servers, it's also possible to use the request batching.
And you can use combination of both.
Yeah, and you can use a combination of both.
Yeah, and it's also the variable batching not only has a use case for the federated subgraphs, right?
Yeah, we discussed that.
That goes into the HTTP specification.
Yeah,
we
I've added the
discuss-
link to the
Okay.
PR, Michael.
Awesome. There's PR. I have to do more work on it, but I just parked it at the moment with the HTTP group. Actually, I have with Benji a couple of work sessions on that soon. But we have an issue on the composite schema repository where we explain the various options there that we discussed. And it will be added then to the next version, not the initial version of the HTTP spec, which is, I think, should come out this year. And then we put it really into the GraphQL over HTTP spec for version 2.
Okay, got it. Yeah, and one another question, like we were discussing that on some previous calls, that currently keys could be overused to pass some arbitrary data to the underlying subgraph. Is lookups could handle this problem, like that you need to pass some additional field, but it's not really a key field. It just
No, well, I think that's what the new require directive is for. So we're changing the way you pass in sort of additional data with Apollo Federation. That's also passed in through the underscore entities field. But in this specification, we're using normal GraphQL variables to do that, to pass additional data to arguments. And that in this version supports sort of mappings to other fields reachable from this entity, similar to the requires directive in Apollo Federation. But within the future, the require argument could also be used for additional contextual data. At least that's the idea.
Yeah.
Yeah, and that's what we also in Fusion we are trying that out at the moment. Like we introduced the $_ Fusion.
Yeah, and
But and I think that's really promising to, like, with this directive, you really can suddenly have the thing that Apollo is doing with context, but in a more natural way, I would say.
Yeah, and that's also something for the future, right? Is that the fetch key, like the key that the implicit key that lookups defines, is essentially can also have more context data, which doesn't need to be necessarily a key. Like you don't need to transport data with a key anymore, because like if you look abstract at the problem, there could be a key ID and you have a require on the lookup. It's not supported and it's not planned, but from a discussion point of view, you could require more data even in a lookup without it having to be the key. You still have to resolve it, obviously, to get the data. So it needs to be resolvable, satisfiable, and you have all the problems that you have with keys, but it doesn't need to be necessarily the identity of the object. You can actually say, you know what, I just require this data. Then you don't have to have this one-to-one mapping, which we have discussed. We don't need a one-to-one mapping between key and lookup. So require could potentially actually just work on lookups as well.
Yeah. In case keys and lookups are like decoupled, how planners should decide
how they do it?
Even not which key to use, but which lookup to use in case they're decoupled.
Have you read the Martin's proposal? Not proposal, but
At the beginning,
a reflection on the topic. He wrote the document. It's also in the Slack channel, and it's also somewhere in the message. And like it's really a good.
I read it. It's still unclear. Like it is more from not from the like designing point of view, but more close to the execution. Like this somehow should be executed. And
but that's easy. Like if you, let's call them exit points, like Martin called them out. Like when you need to get data from another subgraph, then you will look at the possible lookups that there are to get this additional data, and you look at the exit point, basically at the keys that you have in context or that you have to get to fulfill this lookup.
so basically you could not go away from exact matching. Like what I mean here is that keys and lookups could be decoupled in the given subgraph. But
yes, technically yes.
That keys is an entry points, is source points, and lookups as target points, and you could not decouple them, like because you need to do this much.
So if we take all the semantic away, then you could take a lookup and say I'm looking what lookup requirements we have, and I'm looking what data I have in context, and if I have the requirement and they fit together, then you could go ahead.
Can I share quickly?
Yeah, go ahead.
I think one question needs to be clarified, and then this because the execution behavior is exactly the same like it is in existing federation solutions. Take whatever you want, because does this lead to a composition error or an execution error in Apollo federation? Like you have schema A and you have schema B.
I think it would. Yeah, if these are the only two schemas in here.
So that does not.
1 second. No, it's shareable. No, it won't be. Subgraph B do not have entry point, and we could reach to it only from subgraph A, and subgraph A has a skew field. So basically, it acts like implicit key. It's not defined, but you could use a skew to jump. But in case you will add any query which will return product in subgraph B, it will be composition error.
I believe in federation, actually, it should be an error because SKU should be marked as a key explicitly in schema.
No, it's not. But why would it be marked as a key? I don't get it.
So that's
one question, 5 answers.
that's a very important question to answer, because that's the problem I'm having with understanding the entry and exit points, because does this compose and is executable? Like you have you can go in query here, you have all the data that you need to resolve this entity resolver in Apollo Federation. Can you do it, or do you have to annotate SKU here?
You can
No, I think this
you can do it with
This
Yeah,
is
it's valid.
completely fine.
I mean, if all the fields, like if the requirement is that SKU has to be a field, then like half of the entity types would fail because not all of them would have that field. So the jump between the types will be like very limited, I would say.
So we agree that this is executable. Composes and is executable.
I think it should, but as soon as you add like another way of getting to a product within schema B, it would fail.
That's a satisfiability check, right? As soon as you add this, you cannot go back.
Yeah.
Actually, no, you could, right? Oh, no, we don't have the ID. No, you cannot. Okay, that's fine. But yeah, so this compiles. So now the thing about lookups is if we just look at this is what lookup needs to resolve. Right? That's exactly the thing. You're going into this field, you're in this context. What I need to resolve product details. Product details is only on one subgraph. Do I have everything to satisfy a lookup? Yes, I have SKU, and then resolve. So that's essentially the same as I would have a type query here.
But then basically we will replicate what we already have in Federation. And actually, this is unclear behavior. You don't know from looking into schema like where you could jump and who could jump to you. Like when you define a key, you suppose that it acts like a key. You know, in Federation, you match based it on the keys, and then it could be surprised that actually just having a field is enough. And then on top of that, you could provide a field, even if it's external, and it will act in the same way you have provided. And moreover, like you could mark field external, but all fields which are not marked external and the nested paths, they will be also available because like they are in different contexts on different level. And it's not brings clarity. Like,
I mean, cool. Sorry.
Yeah, go ahead, Camille.
It's just that like for me, the information is just in different place. It's not on top of the type. It's just like on the query, but the information is exactly the same in both.
Yeah, but you are like working on developing execution, right? Or planning. In case you're just a user which want to use it, will it be clear for you that this SKU field could be used actually? Or imagine you work in bigger teams like 50 different subgraphs. You just didn't know where you could go. You just wanted to have some field, and then suddenly you will see in query plans that your subgraph is used to doing jumps because it has this field.
That's not true. Because like what this does, the lookup, is actually doing a more natural way like in GraphQL. And GraphQL, if you look at entry points in your graph, it's on the query type. That's the first thing, right? It's just when you worked with Federation, for instance, for a couple of years that you maybe are used to that. But from the information standpoint, we have the same things. We have the keys, which are the exit points where you can shift off. And you have also the lookups where you can enter. And you basically define the same in Federation, right? Just that the reference resolver is defined in code and hidden. Go ahead, David.
Yeah. So my contention here is imagine you're the owner of Schema A, your team. There's no information in this graph to say how important this field actually is. Of course, if you removed it and then the satisfiability graph would be able to point the fact that it can't compose because you can no longer get to Schema B. But like if you imagine in a vacuum that you're making some changes, there's nothing here to say that this is a field that does lots of things. In this case, satisfies this lookup here, for example. Yeah. And that's what I don't like about it not being explicit. That's why I feel like entities in the current like the Federation spec should be handshakes. And in fact, in the Apollo docs, they kind of suggest that they should be handshakes. Like, although you only need a target to be able to go from one graph to another, the docs pretty much say like you should probably have the key defined in this graph and in the other graph, but it's not actually the case that you need to. And for this reason, I think it just isn't clear to the developer what role that field is actually playing until you remove it, and then you get a satisfiability error. But I mean, maybe people have other opinions.
No, I fully agree with that. I think I would much prefer the key to be a requirement here. So the skew key on schema A, sort of adding the requirement that an exit point needs to be explicit as part of the new spec. I think that would clarify things.
So if you make something a key, you require everybody else to immediately have also that as a key.
I mean that's the point, right? If you introduce a new subgraph, which needs data or needs a key, you have to add this key to all subgraphs that provide this key. Otherwise, it wouldn't work because there couldn't be any request routed to it.
No, but I mean, I don't think a field should just like turn into a key because someone else knows how to look up something by it.
No. Martin, he has a key down there. Look at product. You have key SKU.
Yeah. No, but what I'm saying is because that's actually a separate issue. That's defining key as an exit on schema B, which we're not really using. Yeah, but what I'm saying is you also need to define the skew field on schema A to signal that the skew field on line 4 can be used as an exit point.
It's kind of interesting. I just tried it just now with our graph, and it does compose without skew being defined as a key in the schema A product. Like it does let you do that because it does work in that one direction. You know, you can get to schema B's product. Just wouldn't be able to.
Yeah,
I know it currently works, but I think
just tried it.
Might actually be preferable to sort of make it an explicit requirement in the new.
But this could have issues in schema evolvability, right? So it should be a best practice.
But
well, I think the conversation here is actually being on basically the concept of entry and exit points, right? Because the keys were kind of there's non-resolvable keys, true, but for the most part, key was both an input and an output, like the entry and exit, that's why it's getting confusing, right? With the lookups, if you actually make it explicit that the lookup is how you jump to the graph, how you enter the graph, but the key, in order to actually jump to another one, that's what you need to be explicit there. So in the case of the lookups, the SKU would have to be marked as actually a key in order for it to actually compose in the composite schemas work spec. So I think that would have to be a requirement, because otherwise you cannot jump from this one to another without this explicit key there.
The question then is, like, if I have this, how do you, like, if we require this to be here, why don't we require anything to be on here? Because this field we can also not just remove, because that's required here.
It's true. I mean, in a way, requires is a way to just define an arbitrary key.
I mean, they're very similar also from the execution algorithm.
It doesn't even need to be shareable. You know, with the keys, we can even do the argument and say that at least it's shareable, so you know that someone else defines this one too, because you couldn't introduce this one without this being shareable, right? This is shareable, so you know that this is shareable, so someone else defines it too. And I believe the idea or the definition of shareable, correct me if I'm wrong, is that this has to be the same in the whole domain across all subgraphs. So you already know that someone assumes this to be the same thing. Now, with this, we don't have even this guarantee. This could just be something, and it also has an impact. And now we're doing.
There's definitely an impact. There's a dependency here, but I don't think it's different from the dependency between keys. I don't think we.
The thing is, the thing is, I mean, I understand if you would just explain to me that this works because this is shareable, I'm fine. Because
well, I mean that's what it currently does. Like it currently works that way. What I'm saying is I actually agree with what I think was the point David was making, that it's better to be explicit about the fact that a schema offers a certain exit point. So just defining this skew field, even as shareable, should not be enough to use that skew to jump to another subgraph.
Then I understood your gist correctly, right? So this with the entry and exit points in your gist, this would have to be defined, otherwise it would not work.
Yeah.
Right. Okay. So,
but that's not the current behavior.
Yeah. Okay. Okay.
But isn't that overcomplicating things? Because then, like in a setup, when you introduce a key, and you have like 50 subgraphs, like you have to go through all of them to retrospectively make them a key, so you can jump off them.
Yeah, but like
the migration paths will be like defined as resolvable false, and you won't be able to do anything with it. But once you have a way to get to this subgraph or to get to another subgraph, you could unmake it resolvable false. It's the same like problem that sometimes you need to use an accessible when you're doing something, right? For example, for enums, in case you use them, is input and output type. At the same time, you basically will be forced to update all subgraphs, but you can do that at once. There could be workarounds, but the main point was mainly that it will bring visibility. It will show the connection between subgraphs, like how exactly you could interact. Like you will know that, okay, this set of services, they have ID. This set don't have ID. In case I want to talk to that services, I need to somehow get a skew, and then I will be able to talk to that group of services. And it will be like more fine-grained contract, basically.
David, sorry that we didn't ping you.
So sorry to open up a can of worms here, but I don't think it's a good argument to say like, what about requires? Like we don't have a contract for requires in another graph. That means it's a bad idea. I mean, personally, I think you would have everything that's explicitly used in another graph in lookup or in requires or whatever. It depends, because like requires is not, you could get it from anywhere essentially, right? I mean, any graph that offers that field. I think the contract should always be explicit, but I'm also of the opinion, like, for example, take these graphs. If you added a new schema C, and then you don't need to do it, products and you added SKU, you would have no issue, as long as you put shareable on SKU in the new graph, you would have no issue adding that field, and it could return completely disparate data because you've not had a conversation with any other team, just because it was already marked as shareable. So as soon as the first shareable instance is created, then there doesn't need to be a conversation anymore. It's only the first one when you would get a composition error. This field is not shareable in schema A. Talk to the schema A team. Okay, let's make it shareable, blah, blah, blah. The contract is defined. And then when another team comes along, schema C, product SKU, they can just stick shareable and they could return whatever they wanted, because there doesn't need to be a conversation because it's already been taken care of. The power is in the first person to put shareable, and then, the first two graphs to put shareable, the power remains with them. This should be, in my opinion, explicitly who is sharing what with whom. And I know this is going to get quite verbose, but to actually get the intention of shareable to be complete, it should be explicit about who is allowed to take responsibility for that field. Otherwise, you basically give it away once and everybody can take it. Am I making sense?
Yeah, so you basically want to say that you want to share this field with A, B, C.
Like
I think this would become unmaintainable with larger graphs.
Yeah, correct. It's quite verbose, and there's problems with the fact of how verbose it would be, and like if you had 100 different graphs, like it does get unmaintainable. But
How would that
whole-
work in Netflix, Stephen?
But the whole idea behind shareable is that you open up a conversation between disparate teams to make sure that the same data is returned. But that goes out of the window once the first instance is made shareable. That's the problem, and I think it's not fully solved.
And I think to sort of bring it back to the key issue, I think marking something as a key, like including a field in a key, is a stronger statement than just marking it shareable. Like you're saying something more about the semantics. Like it should be unchanging. It should be a durable identity. So I think that's actually an extra argument for making the key explicit and not relying on shareable in that case. That's a separate issue from the issue you were bringing up with shareable in general. But I think with keys, it feels like something that should be should be stronger. Does that make sense? Or
Yeah, I think we have a lot of different targets here, because a lot we talk about is schema governance, right? Like, well, how do you that's one hot topic, right? So how do you make sure that you don't run into a wall when you have 50 teams working on the same graph? And we try to enforce this with some restrictions on the schema. But what we should also not forget is that maybe you don't have 50 teams, right? So that's from an implementation perspective, it's a trade-off that we have to do. How much do we want to force best practices or certain pattern on top or into the main specification of composite schema, and how much should be as an addition on top? Like, you can do composite schema with less information that works for smaller enterprises where people drink everyday coffee with each other. Whereas it doesn't work if the teams are spanned across different time zones and different countries. Then you need more restrictions so that you don't interfere with each other. And it's just a bit, if you think about the ones which work together in the same office and can talk to each other and can hit each other if they break the graph on def, then it's different from a big enterprise which works in multiple time zones. And
yeah,
I have the feeling personally, the main specification should tell how we work with composite schemas. And if we want to make something which works at big scale, then there could just be additional behaviors that we put on top of it. It could just be like, this is the set that you need for composite schema to work. And if you want to enforce more rules, that's schema enforcement rules, schema governance rules, or let's say the composite schema government rules that you can implement, where you can say, if you want, like, I need to explicitly say shareable. But maybe you don't want this. Maybe you just want to say, I need to enforce keys across everything. You know, that's a bit the thing. Like, do we need it in the specification that does the transport, and do we need to lock ourselves down? Or can we just add something on top, and your graphical server can be composite schema capable without having these restrictions? That's, I believe, one question that
I would definitely say the sort of the shareable issue that David brought up, that seems like a good use case for a governance layer. Like the first time you add if someone like makes a field shareable that's already shareable by other graphs, maybe there's some kind of explicit process that you have to go through, like on top of the basic spec. Like that makes sense as a governance process. But I think the being explicit about keys, that feels like a core issue to me. I don't think that's something that you want to leave up to a governance process.
So yeah, I mean,
I don't know, Martin, about this specific example that we have here, where you introduce a new lookup and you introduce a new key, but you already have fields shareable. I think this could block a lot of, or this could introduce a lot of issues. And this could be solved by tooling.
Yeah, I mean, I have a hard time seeing a scenario here where a field, an existing shareable field, is suddenly used as a key, but maybe I just need to see a concrete example of that.
Yeah, I'm just worried if we make it so strict that we require it, that it kind of becomes unwieldy. I mean, in general, agree with you, right? But and it should be a best practice, and maybe even we should warn about this, like Derek suggested. But I don't know if we should just say you're not allowed to have this.
Yeah. The question is, if a key is not equal to the fetch key, or the fetcher, or the lookup arguments, if we define this, and we have already, that this doesn't need to be a one-to-one match, theoretically, there's nothing that prohibits me to do this. I'm not saying that this is good best practice or whatever.
We're, by the way, at time, Pascal.
Yeah, I know.
Yeah.
But it's just that.
Oh no, but I agree that key there was only necessary if you wanted to be able to exit this product on this subgraph. You don't need it for the lookup.
Right.
Yeah. So I'm reworking the lookup chapter a bit with the input from this meeting. So I'm kicking out, if nobody is against it, the nested lookups. I'm making the I will use the entry point wording from Martin to make it more explicit. And I'm not sure yet about the exit point wording.
Yeah, I mean,
but yeah, I'm gonna rework it a bit in the pull request, and then I think we need 2 more meetings about that, and then then I think we are all aligned.
Sounds good.
Awesome, guys.
Very optimistic, but yeah.
Yeah, I mean it's getting closer, right? We reopened this, and I think we made progress.
Well,
today.
it only took 6 months last time, right? Last year.
Yeah, I think in general we are agreed on most things.
Yeah.
It's more nuances, I think.
Yeah, this is good discussion though. Brought up a lot of these.
And then we have also Steven's suggestion on keys. We're gonna bring that up next time.
And we also have to discuss Shane's topic about the entities, because it's important to know what actually is an entity. If you just say it's identifiable by key, then all lookups return entities, because there is some kind of key, some kind of stable identity that you have already. By definition, the lookups has to be stable. We defined it as an idempotent function that returns based on arguments some things. So by definition of lookup,
but no, because that doesn't tell you that field uniquely identifies that entity. Like there could be, without the key directive on line 20,
but it has to, right?
There could be multiple products with the same SKU.
But if you're calling this a lookup though, then you're saying that it's not. They're saying this is unambiguous because this
No,
is
the
how I look it
lookup.
up.
This is one thing we have to really make clear, that the lookup is stable
Yeah, I
for,
think
for the executor.
if you eliminate the nested lookups, which would actually break this one-to-one relationship between lookup and entities, so no, don't do nested ones, then I would argue that lookups will always return an entity, whether it's being extended by another one or you jump from this one to another one, but it's always going to be an entity, right? I don't see a use case for a lookup that doesn't return an entity. With the nested lookups, when you have the hierarchy of it stuff, yeah, like the part of it may not identify something that is branchable, but the single level lookup on the root level, or like the namespaced one, I think that's fine.
Okay.
Okay, let's take that up next week.
Yep, sounds good.
Okay, guys, see you.
Thanks, y'all.
All right.
Yeah.